Hi everyone, in this video solve example 3.1 from the book Applied Thermodynamics, McConkey and Eastop from chapter 3. A mass of 0.05 kg of a fluid is heated at a constant pressures of 2 bar until the volume occupied is 0.0658 meter cube. Calculate the heat supplied and the work done when the fluid is steam, initially dry saturated, when the fluid is air, initially at 130 centigrade. We need to calculate the heat supplied and the work done. Its initial conditions are given when steam is dry saturated and when there is air, and its initial temperature is 130 centigrade. Then it is heated at a constant pressure up to constant pressure 2 bar until its volume V2 final volumes is reached to 0.0658 meter cube. Let's write first the given data that is given in the statement 3.1. So let's see, pressure P1, mass of the fluid that is given, it is 0.05 kg. The pressure P1 and P2 is same because it said that the process taken place at a constant pressure, then it is 2 bar, means to say 2 multiplied 10 to the power 5 Newton per meter square. The final volume is V2 and it is 0.0658 meter cube. We need to calculate the heat transfer and the work done by the fluid. Some initial conditions are given when the steam is initially dry saturated. Initially dry saturated means that when you see from the saturated steam table, the V1 value will be equal to Vg and the H1 value will be equal to Hg. This dry saturated means that. In the second condition, it said that the fluid is air and its initial temperature is 130 centigrade. To convert that into Kelvin, just add 273 with it, then you will get the T1 value in Kelvin and it is 403 Kelvin. Now come toward its solution. First, let's come toward the initial state of the steam. The initial state when the pressure P1 is 2 bar, the steam condition were, so at pressure P1 2 bar from the saturated water steam table portion, we can see that at 2 bar the V1 specific volume V1 is 0.8856 and the H1 value is 2707 kilojoule per kg. So I can say that V1 is equal to suffix Vg value and it is 0.8856 meter cube per kg. Here you can see at 2 bar and H1 is equal to Hg1 value at initial state and it is 2707 kilojoule per kg. The V2 volume is given, final state volume is 0.0658 meter cube and also its mass is given. Then its specific volume at the final state V2 is equal to total volume divided by mass of the steam that is present. It is 0.0658 divided by 0.05. After solving this, you will get the specific volume at the final state. It is 1.316 meter cube per kg. If you see that this specific volume and this pressure P2 that are our final state lies in the superheated region. This is portion of the superheated steam table. This is the pressure 2 bar. This is the value of specific volume. So at specific volume value 1.316 meter cube per kg, the corresponding enthalpy H2 value is 3072 kilojoule per kg. So I can say that 2 is equal to 3072 kilojoule per kg. We have seen this from the superheated steam table at pressure 2 bar and specific volume 1.316 meter cube per kg. You can see also from the portion of the steam table, here its value 2 bar and its corresponding specific volume is 1.316 meter cube per kg. Then its corresponding enthalpy value is, here it is. Now the heat supplied is equal to m into change in enthalpy, and change in enthalpy is H2 minus H1. What is H2 value? There is 3072 minus mass is the steam is 0.05 into H2, 3072 minus H1, it is 2707. After solving this, you will get the heat supplied to the steam is 18.25 kilojoule. Now let me draw the PV diagram for such condition when the steam is initially dry saturated and finally the steam is superheated. Then for such case, the PV diagram will be look like this. Initially the steam is at a saturated line, then heat is supplied and expansion is taken place at a constant pressure. This is the constant pressure line. Here the pressure P1 and P2, that is 2 bar. Here initial state, this is final state. Here the specific volume is V1. Here the specific volume is V2. This shaded portion represents the work done by this, and it is equal to mass of the steam present, pressures and change in specific volume. So I can say that the work done by the steam is equal to mass of the steam present, pressure as it is occur at a constant pressure, and change in specific volume. Further upon simplifications I can write, now just simply put the value. Mass is 0.05, pressure is 2 bar, means 2 multiplied 10 to the power 5, then V2 is 1.316. So after solving this you will get the work, and it is 0.05. Multiply these simplifications, you will get, that is 86,080. Multiply this with this value, you will get the final work done by the steam, that consists the mass of 0.05 kg of steam, and it is 304 joule. Divide with 1000 to convert into kilojoule. It is 4.304 kilojoule. This is the work done by the steam. So here you will write the negative sign. Now come toward the second condition, in which the fluid is steam, in which the fluid is air instead of steam, and its initial temperature was given, that is 403 Kelvin. Also in the statement it was given the volume is 0.0658 meter cube. The R value for air is 287 joule per kg Kelvin. The mass of the steam present is mass of the air present, that is 0.05 kg. Now from general gas equations, P2 V2 is equal to MRT. Divide both sides with MR, so you can get the T2 value. Just simply enter the corresponding values. What is P2? That is 2 multiplied 10 to the power 5. V2, that is 0.065. After solving this you will get the T2 value, and it is 917 Kelvin. Now the T1 value is already given. The T2 value has been calculated. Then we can easily calculate the heat supplied to the air, the working fluid air, and the work done by the air. So Q is equal to mCp delta T. Cp is constant. Now just simply enter the value. Cp is 1.005. Change in temperature 917 minus 403. Now just simply multiply this, you will get the heat supplied to the working fluid air, that is 2583 kilojoule. So you will get heat supplied 25.83 kilojoule. Next is the work done by the working fluid air, that is equal to mR delta T, that is M, that is 0.05 multiplied by R value is 287 joule per kg Kelvin. So you will get the work done by the working fluid air is 7380 joule. Divide 1000 to convert into kilo. So you will get the work output by the working fluid air is 7.38 kilojoule. When you supply such amount of heat, you will get this amount of work done by the fluid.